I think we're going to do direct processing as a follow-up. I'm still working on getting that connection established. So we'll jump right into working on tiles with the carrier overview. And so we have a plate that we just pulled out of the fridge. It is still warming up to temperature and condensing, so we're going to give it a minute as it does. In the meantime, what I'll do is I will start to kind of go over the tiling setup here and show you a little bit about what that looks like. So just to keep things simple, I'll maybe move to a confocal track like this one here. And from there, what I can do is start with our tile function here. You'll notice that pretty much every configuration that I have set up includes tiles activated, even though it doesn't necessarily have any tiles there. I do recommend doing this because that way, if you create previews, if you're working that sample navigator, then you can end up basically carrying the preview windows and everything like that with you across different configurations. So you can switch, for example, from area scan to multiplex to confocal easily by having this tile activated. Otherwise, when you switch, it'll ask you if you want to save it, and then you can, of course, open it back up again, but it's a little more work, that's all. So under tiles here, again, we had been working with this tiles and positions and everything. Let me begin, as we always do, by showing the viewer. And let me also remind you that if you are doing this with the AI sample finder, you would actually have this automatically come up. So I'm trying to show you starting it from scratch without the AI sample finder here, just to give you an idea of what that looks like. So you just need to click this little show viewer button here. We're going to skip tiles and positions for now, and we're going to move instead to the sample carrier. And you can see that it's been defaulting to give me a slide for some reason on this, but I can select and I can end up seeing a long list of different options that are available here. And let's just maybe open this up a little bit. Let's maybe expand that a little bit. So a lot of different slide type options. There's even Argolite now. We have a couple of different 4 and 8 well chamber slides as well. And then we can get to the multi-chambered slides as well. And so something like this 384, I'm guessing might be what we're after. And we have multi-wells also, which are going to be these round ones instead. TEM grids, slides, petri dishes, you name it. For some of the very simple things like a microscope slide or like a petri dish, it's really not worth going to the trouble of doing a carrier unless you really like it. But for some of these things like these multi-chamber 3D4 wells, it can be very nice. We're going to try to go with the defaults for today, but if you have the ability to go online and get a download of the dimensions for the plates that you're working with, and most companies will offer these online. If you have the ability to come up with your own, then we can right-click on this, for example, and I can copy and edit it. I mean, first of all, let's take a look at what it looks like. So let me just show and edit it. So this is basically the details for this 3D4 well default that we have selected. And you can see that we have a certain size, height, and width. We have the ability to write in the number of columns and rows we want, the type of container, whether it's round or square. And then we can do the height and the width of these in terms of XY dimensions here. And then we can talk about the distance center to center as well. And if you have a plate that doesn't have the well centered across the entire area, you can actually give them a separate offset from left and from top so that you can have a more offset type thing. And so this is basically all of the dimensions that we would work with. And if I cancel out of this, then the other thing I can do again would be to copy and edit. And here you'll notice it gives me, there it is. Gives me basically the same kind of thing, except now I can modify these dimensions. So again, if you can get these from online, then you can punch this in and make this exactly specific to your own multi-well. And then you can basically give it a name and use that one every time. All right. So as I said, we'll try the default. I'll click OK. And you can see that that just immediately changes the tiling interface here to be able to work with this particular carrier. What do you think?
Probably fine.
Okay, I can keep talking if you want to wait a bit.
Give it a go.
Okay. You want me to do it? What's the easiest way to get started? Do you want bright field or do you want fluorescence?
That's a good question. Let's just move to one of the, so it's going to be M and N.
Okay, it's not going to work yet. We still need to calibrate.
Sure.
But
Can we calibrate first and then we can use that to navigate?
Yep, we can try. But we do need some way to look at it basically. So let's just make sure that bright field is going to let us see our different wells, and maybe what I'll do is I'll get you to try to move up to the top left corner.
Okay.
It's on the right. We're at 5x right now, so I guess we can just focus on the edge of the chamber itself.
Can you turn the light on?
Yep. How's that? I'm on the 5x right now. I can switch to 10 as well if it's easier. You got it?
I just it took a minute for it to come on.
Okay, great. Okay, great, awesome. So we're in bright field mode right now. What we're going to do first, we know that we have a well that has, or a tray that has wells that are seated from, what was it, M and N, and then just a few of that row as well. So the first thing that we're going to do, and you can see that we're already pretty close to where it should be. So it's not like it's really ever going to be that far off, but you can see that we do need to do a little bit of adjustment to get this calibration working. So the first thing that I'm going to do to set ourselves up is to do that. What I'm going to do for this, I think, is I'm going to go to our channels tab, and I'm going to add a channel that is going to be bright field, because these two confocal ones probably aren't going to help me much. So let me add a track. Oops, not that track. Let me go to imaging setup. Let me add a wide field track. And we can tell it that we want bright field. And you can see that you can't do confocal and wide field at the same time, but I can at least add it to this configuration so that I can get myself started here. And I'm guessing that those settings will be all right. So let me maybe go live and see what we're looking at. Super bright. All right. So I'm guessing that this is the edge of our well here. Is that right? Yep.
Yep.
And this is the very first one. Is that right?
Yeah, it's the other edge.
Awesome. Great. Easy. For such tiny spots, this makes it very simple. Okay, so we're ready to go with this. And the reason why I did that was so that I could use this channel to do my calibration. So what I've done so far is I have chosen a carrier, and now I need to calibrate it. So I'm going to click on this button here. You can see it's giving me that bright field channel that I had selected. And we can go now to the next setting. We could calibrate the stage. We really don't need to do this, but we could set this up as part of this process if we wanted to. We're actually going to try to set it up so that we can automate that when we start the software instead. So it just kind of does it automatically before you really load a sample or anything like that. I can tell it that I want to do really two important ways of doing this. One is to search the chamber edges at 7 points. And what this is going to do, and you'll see it as we move on, is it's going to ask you to do all 4 corners or all 4 sides of A1. And then it's going to ask you to do 2 sides of A2 and 1 side of P24. So that'll give it all the information it needs to know how big the wells are and the distance in X and Y of the whole plates, and then the rotation if there is one. The other way that we could do this is with this search chamber with center points. So especially with this 5X and this, the size of these wells, this almost may be a nice way to do it. And what this will do is a single position in the center of A1 and then A2 and then P24. But I'm going to run through the more thorough one here. We could also just do one single chamber, or we could do one reference point. So these ones you're probably never going to use. They don't really let you get the full sense of what your plate is doing. So let's try doing the 7-point calibration. And you can see what it's asking me to do right here. And so basically all I need to do is move the joystick like so. And as long as I have a sense of, where my edges are, I can try to get myself roughly halfway. The crosshair that we have on the image makes it very nice to help me basically figure out where this is. And let's say I want to choose, let's go roughly in the middle here to call it the edge. And at this point I can say set position. Now I can go do the top one. This is going to be a little bit easier because this camera is kind of about as wide as the well. So like so, move up to the top. Again, set that here. I'm doing this with the joystick, but honestly, it might almost be easier just to use the double clicking like so. And roughly like that looks pretty good. Set position. Again, I can move down here. Oops. Something like that, set position, and we're basically done with this position, with this well. You see that it has, that it is all checked here as well. And you'll notice that there's a button that I could have chosen that would say move stage automatically to each required position. I definitely do this when I've custom created my own carriers. I'm not quite sure I'm ready to do that here, but let's see how we do. Once I'm done this, I can click on next, and I can tell it that I want to try to move the stage, and we can give this a shot. You ready? Mm-hmm. Okay, so if you want to, it should be easy enough just to jump like this. Let me know how it goes. Decent. We're a little bit off, but I'm willing to bet that that's the last well.
Yep.
Yep. All right, so then we want to go to this position right here. So we were pretty close, honestly. Call it something like that. Again, we can set that position. I trust it now enough that I can do this to move stage automatically to each required position. So I'm just going to hit set position. Should go close to the top. Again, I can set that as the next one, and we can go next. I can tell it I want to move stage. Pretty close. Mm-hmm. And we are done with calibration. That's it. Takes a little bit at the beginning, but hopefully it seems pretty easy. And now basically what we have, especially, can we remember exactly which wells it is? It was M for sure, I think, right?
M and N.
M and N, okay.
And then there's 2 empty rows on the edges.
Oh, on either side?
Yeah.
Okay, great. All right, so we could maybe just go over here.
Yeah, there's some there.
All right. So you can see that we can easily navigate around like this. I don't know if we're going to get a lot with the 5X, but maybe let's just see what our bright field looks like for the moment very quickly. There's some stuff. All right. So maybe what I'll do is I'll switch to 10, at least we have a shot at looking at something. There we go. Okay. And if I want to, I can basically just turn that off. We can try our 48. Do you know what this is labeled with? I think you might have even mentioned it this morning and I completely blanked.
Try green.
Yeah. We'll probably even get autofluorescence if there's nothing else on green. We're still kind of warming up here, actually. So we did take a break and they went into standby. There we go. Not that it helps. Apparently. You can see as we're starting, because we did break for lunch, that the diodes were in standby mode. So it just takes them a few seconds to start up, but we might as well just wait for them to warm up before we keep on going here. It might be that we need to go to even higher power to don't see much of anything too. I'm not sure.
You could try the well over too.
Yeah.
Okay. That doesn't make
All right. Clicking too fast. It seems to be in a good spot. Maybe I will just switch to the 20. Let's see. Oh, really? Okay. What is what are the cells? What are we looking for?
Looking for tiny condensates.
Okay.
Maybe with low power state.
Well, we can continue playing with this to try to optimize it, I guess, as we keep on going. But if I'll give it one more try here with the 20, and if we need to, then I might just talk about tiling in the context of setting everything up and working with Zen and the tools, and then we can spend time trying to optimize as part of the sample run and stuff like that. There's something, maybe. Interesting. They're a pile. It looked like that from the bright field too, but they look like they're really pretty piled up there. Yeah, wow. All right, let's at least work with something that we can see. Let's try red. All right. Okay. Well, we're going to continue to optimize, I think, as we get set up later on. But just to quickly run through how you work with the tiles tool for this. Yes. Great question, Brandon. I know we already talked about this yesterday, so that'll definitely be a question that we'll get to as we go. You'll notice that I'm working now with just the 10 and the 20 so far, the dry objectives. Partly that's just for ease of use to kind of move around these things. But that'll be part of the end of the conversation, I guess, as we work with this. So let me go through just the tiling tools first, and then we'll get to that in a second. So the reason why we work with these carriers is because it can make it, number one, a little bit easier to navigate around. So I can easily move between these different wells. I can see basically a representation of the whole tray. And so I can easily jump back and forth between these different wells. But even better yet, what this does, especially when we're looking at the kind of scale of number of images and number of wells we need to work with here, is that it gives me pretty easy tools to be able to work with these wells to set up either tiles or positions. And so if I work in this tiles advanced setup window, if I take a look across the different tile options that I had, again, remember at the bottom of tiles, at the bottom of positions, we have these different carrier options. And so if I know that I'm working with everything from M to N, let's say we'll go out to 10 or something like that, I can easily just basically select them all here. Alternatively, I could select them here, which is a little bit tougher, but I could do it. And so we can basically just select exactly what we want. And that'll be highlighted down here as well as right here also. From this, for tiles, it gives me a couple of different options. And I can either try to fill a certain amount of this, or I can just choose a defined number of columns and rows. So if I want to do something like a 3x3 tile here, I can choose that. And I can click add, and you can see that it just very quickly adds that tile region to everything. Okay. The other thing that I can do is, let's get rid of that. So as I mentioned, I can do fill factor as well. So let's say that I want to fill maybe like 30% of that area. And if I add that here, you can see basically what it does. So two quick ways to really create tiles across every single well consistently together. And same thing goes for positions. So with positions, whatever ones I have selected, I can basically go through and either distribute these as a grid or as a certain number. And these are going to look very familiar to the other ways that we had done this before. So grid is kind of like one of the arrays that we can do. So let's say that I want to do, you know, a 3x3 grid with a minus 100% overlap again, and add that, and that'll basically give me grids that are, or positions that are spread out across the entire well. All right, if I did it with number, then this is where, and it's picking the numbers that I had set over here before, you'll notice. And so what I can also do is the same kind of either randomization or just straight up positioning that I had been doing in the past. So this is going to look very similar to what I had just done. I could randomize this. I could bias them towards the center, for example. And so you can see kind of how this works here. Everybody good so far? These kinds of trays, especially, you know, the surface is not flat generally. There's a lot of curvature to it where it bonds the plastic and so forth. And so we know that it's not going to stay in focus across the entire area of this, even just for these few wells. And so one of the things that, and never mind that, by the time we start imaging this many positions or this many tiles, we probably don't really want to have to do the verify focus that I had shown you before. So you can see here for all of these different wells in this position array that we have, you know, for each one of these, all of these different all of these different positions. And so I don't really know what my focus is technically, so I would need to go in and verify these. And you can see that that list, as we get all of these different wells, is going to be longer and longer and longer. And I would hate to do that to anybody. So especially for these, this is where it really does make good sense to choose something like a focus strategy, like definite focus. And we can either choose it right here up front, as the focus strategy of choice and just use definite focus to assign a set distance above. Or what we can do is still use these Z values. And in this case, probably what I would do is to go down and actually verify these, but rather than do the manual way, just basically tell it to use definite focus to be able to identify all of them. In a nutshell,
Building and Gathering, designed by James A. Wilson, is published.
I'm sorry?
Sorry about that, accidentally unmuted.
Oh, no worries. Yeah, so this is in a nutshell how we would basically set this up. Highly recommend things like definite focus. Again, this does require that your sample is generally a set distance off the cover slip. So that's something to consider. One of the questions that we've had already is basically, you know, how close can you go to the edges of this thing with the different objectives, right? Probably and it's worth mentioning that we talked about the different working distances for each of these objectives. Your 10x is about a 2 millimeter working distance. Your 20x is about a 500 micron working distance. Your 25x is about 570. Your 63 is about 170. So that is the space between the objective and the focal points or your sample, including the cover slip, that is. So you don't necessarily have a lot of room to move before you bump into it with these higher mag objectives. And not only that, the surface, the top surface of the objective is relatively flat for many of these objectives. The 63 especially has a very shallow front piece. The 10x has a lot more angle to it. The 20x is also very shallow, so that one comes up pretty close, and you might not be able to get too close to the edge of your plate without having it strike the edge or the skirt of the multi-well plate.
So,
Yes.
So one thing that you can do though is multi-well plates come in different skirt heights.
Yes, that's.
And so
okay.
they're what we call low base plates. And so a low base plate will basically, your imaging substrate will be flush with the skirt. And so you don't have that problem of hitting the objective lens or the edge of the objective lens against that skirt, because it's at the same exact height as your imaging substrate.
Yep.
They tend to be more expensive than the skirted, but it's worth it. You know, if you really want to maximize your imaging space, then a low base or a ultra low base plate is the way to go.
Thank you. That's exactly what I was going to say next, but it was a lot more eloquent than I was actually going to, and more detailed than I was going to get into. So you've obviously done a lot of that before. The other thing that I would say is, you know, if you're working with a new plate, I highly recommend, I mean, work with your core, work with Cassandra, work with Brendan. What I used to do to figure it out would be to, you know, take off the objective and, you know, add a little bit of oil to it and just look at it with the well and figure out how close I can get before the diameter actually bumps into it. So, you know, there's crude ways that you can kind of rough out how close you can get without trying to do it on the stage where you run the risk of damaging the samples. So that is definitely a really important thing to consider, and it's important to consider before you even walk up to the microscope. Silence is golden. We are going to, so I think, and the other thing, I guess, obviously, is we're talking about immersion oil and everything as well. And so I know that a lot of people are imaging with this already. I can tell by the stage insert. And so I do want to point out this one right here, which is this little move focus to load position between container. So this is a blessing and a curse in a way, I guess. what this allows you to do is to drop the objective down a couple millimeters to a loading position, move over to the next position, and then come back up between different containers. So if I'm doing 10 positions in each one of these wells, it'll basically do all 10 positions, and then it'll drop down and move over to the next well and come back up. And especially for, you know, systems where you don't just have a single cover slip sheet, this can be quite nice. But the other thing to mention is if you're doing this with oil immersion, then the problem can be that you can end up introducing air bubbles eventually if you're not careful. So there is that. But the other nice thing is that it means you don't drag your oil all the way across your tray such that you end up losing it quicker and you can go further. I don't know what kind of rules you want to have in place in terms of oiling. Yeah, good. All right, so that's as much as I'm going to talk about for now. Work with Cassandra and work with Brandon to basically figure out the specifics, both in terms of which objectives are suitable for different multi-well plates, and secondly, for strategies that you can use when you need to apply oil to be able to cover larger distances on your tray. What I would like to do, I want to set up an experiment where we basically have all of this in place with the focus strategy so that you can see it kind of start to finish. We do have about 20 minutes left in this session, but we have some optimization to go in terms of getting this working and kind of figuring out exactly what we want to do. So I think, honestly, if nobody has any other questions, I can't really think of anything else to mention here that will be relevant at this point until you really start working with it. I don't think that there's anything to say in terms of options for this, or actually I will say one thing. There's a setting that we have in here that's always default activated, and it's one that is basically letting you sort things. And so you can either sort by Y and then X, or sort by X and then Y. And the purpose of this, especially, you know, outside of working with the tray type features, let me just add a few different points here, kind of over the tray. So let's say we want to do something here, like so. So I created I created position 1, position 2, 3, and 4. And if I'm sorting by Y, it'll basically come down to position 2 first, and then 1, and then 4, and then 3. And the point is to try to save you time as you're traveling across larger areas. The thing that it does that you might not expect is that it will order them then that way in the final image. So if you ordered these 1, 2, 3, 4, expecting to see those show up in that order in your final image, you will be surprised. And so it'll show you them in the order that it collects them. And for that reason, I often uncheck this box and just leave it like so, just because it makes it a little bit easier to figure out what you get in the end. Now, that being said, if we were to go through and collect this image, you can always go to the slider to move between different positions, and you can tell which position they are. So it'll give you a readout of exactly which one it is. It's just that it's not the order that you expect. All right, so I often uncheck this tile region and position box. These other ones are fine. Traveling in tiles, you can either do meandering or combing or spiraling, whichever one looks great and works better for you. Same thing goes with carriers in multi-well trays. You can either meander by going right to left and then left to right, or you can comb. All right. Don't know if there's much more to say about this. This split scenes into separate files is always very helpful as well. This is something that you can end up using to be able to keep file sizes small and separate things if that's the way you need it for processing downstream.
So can we just do one test where we image just some bright fields?
Yep.
And just one field of view, or
Sure,
yeah, one
like-
field of view per well?
Yeah, absolutely.
Just in that little bottom.
Sure thing.
Yeah. I just want to see how the
what it looks like.
ultimate focus
Yeah.
performs, or
The definite focus
whatever you
performs.
call it.
Yeah, no problem. And that's the one thing that I wanted to kind of record as well, because there's one step at the beginning that you need to do.
Okay.
So I just kind of want to show what that looks like. So let me get rid of these positions. That's a good idea. We can do it that way. So let me just get rid of all of these basically. So let me get out of that. Let's go back to here. All right. And so do we want to do our M3 to M10 again? Something like that?
Let's do N
Oops.
and N. And let's take it all the way to 15. I kind of want to get like towards more the center
Okay.
of the plate.
Sure, yeah, that's fine. All right. And we just want to do a single position?
Just a single position.
Okay.
That's good enough to determine whether or not.
Yeah, of course. Oh, I'm randoming.
Yeah, no. That's done.
There we go. All right. So if I'm going to use definite focus, basically, I'm going to just move over to our first position here. Zoom. And let's then let's turn up our confocal. Let's just do bright field. It's a great idea. Thank you. Let's go live. Let's see what we've got. Again, I'm clicking too fast for everybody here. All right. So if I'm going to be working with definite focus, I'm going to basically set it up like about so.
Uh-huh.
And if I think that that's a decent focus for this, I'm going to leave it right there. And in my focus strategy, as I mentioned, I'm going to do just definite focus. That's it. Okay. We're going to do it at every single position. Makes sense. And that's all I really need to set. So very easy to set this up for multi-wells if we can do it this way. When I hit start experiment, it's going to warn me that it wants to initialize on the current position, make sure that my focus is where I want it to be and the position is as a suitable location to facilitate this. So I predicted that already. That's exactly why we moved to position 1 and why we focused first. So if I hadn't, I could go to live, I could do everything that I already just did. Once I'm finished, I'm going to hit continue experiment and it's just going to go ahead and do it. And you can see right beside the little pause experiment button over here, every time I collect an image, there's a tiny little flash of a definite focus stabilizing for each one of these. So basically what it's doing is when I hit start experiment, it wanted me to be in focus on my sample.
Mm-hmm.
And after that, definite focus then found the cover slip, calculated the difference in microns between the two, and that is what it's applying to every one of these wells.
Yeah, it looks like it kept it pretty consistent.
Yeah. And so here, as I mentioned, like when you're taking a look at these different images, you can hover. You can see that this was position 1 in well M9. So, oh yeah. And so all of this information is saved as part of the metadata as well. So we definitely keep all of the information both on the well and also on the position. So that's nice. Look all right. That's exactly how we would do it. So for anything that you're doing with definite focus, that's exactly how we'll do. I guess since we have 15 minutes too, maybe I will show you also the other definite focus, which is over here, which we haven't really talked about much either. So this one works, as I mentioned, it's not really integrated into the experiment, but it is a nice tool to kind of help you get started, help you localize things, and to keep in focus as you're, moving across a lot of different regions. So similar to what we just did here, what I can do with definite focus is if I'm at this position I can try to find my surface. Again, this will find the cover slip surface. Once I've done that, I could go to live, for example, and I expect I'm going to be close, but maybe not exactly where I want to be, although actually that's really, really good. So let's pretend that that's what I'm happy with in terms of focus. I can store that. And to be perfectly honest, I didn't even need to do the first step. If I go here first, if I go live, if I focus it and find it where I like, a sneaky trick is that you can just hit store focus. That's all you need to do. Once I've done that, I can hit lock focus. And when I do lock focus, then no matter where I go, let's maybe tuck that out of the way. No matter where I go, you can see that it'll basically keep this focus for me as I move between all of these different positions. So again, it's applying that same offset to every single one of these. And this is why I say that this is really, it's basically just a handy tool to help you navigate as you're moving around between different regions. And you can see it's doing a nice job keeping everything in focus, even though we've moved over halfway across the plate here in this case. Oh, there's something in everything. Maybe not here. No, yeah. All right. So this is how to use definite focus on the right-hand side. And again, it's handy, it's helpful when you're doing live mode or when you're doing by eye, keeps you from having to hit that focus knob all the time. But other than that, this isn't what we're going to build into our experiment. All right. With all of that said, I think if I say much more, people are going to leave or fall asleep or something like that. Again, if you have any questions whatsoever, please don't hesitate. We're going to be around till the end of the day. So we can even leave the chat open potentially, and that way you can just chat questions if you want. Not sure if we'll keep on sharing the screen, but I guess we'll see how it goes. I don't know, did you want to record this part afterwards? Yeah, sometimes it goes great. Sometimes it's like meh, but
It's meh.
we just stop. Yeah. All right. Sounds good. So we're going to keep on working with this slide again. If anyone else has material that they wanted to work with, now's the time. It sounded like there were one or two that we might try to work with. And so I hope that this has been helpful. In a way, this gives you basically full exposure to confocal, spectral, area scan, multiplexing, and all of the different multidimensional aspects. So tiling, Z-stack time series. There are a few things that we haven't done. So in a way, we almost only scratched the surface. So the things that we still need to talk about include experiment designer, direct processing, automation, even we can do bleaching as well. That sounded like at least a couple people would be interested in this as well. And there are also a number of different topics like image analysis and Intellisis and ZenFlow and a whole bunch of different things that your system, which is packed to the gills and would have been my dream confocal in my core facility, can do that we'll need to cover. And some of these we can just do as an offline session, I think, or like a remote session, but there will be a few more of these to come that I think will be hopefully a little bit more purpose-driven, single topic, shorter, and really, working with samples, especially as you have them and specific needs and applications come up. And with that, I guess, thanks very much for your attention. Looking forward to hearing news about how the system is working for everybody. So I'll definitely be in touch to try to find out how things are going. And we'll set up another couple of these sessions in the next couple months.
Great.
Take care, everybody. Thank you.